geometry. Call this proofs video number 1. This is should be placed after having done section 3.2. You should have received this worksheet in class. I would highly recommend that you try each one of these proofs and get as far as you can with each one of them before resorting to this video to fill in the blanks if there are any. Okay, so if you haven't done that yet, pause the video and please attempt each one. As I've said in a previous video, everybody can make a T-chart. Everybody can put statements and reasons, and we're abbreviating that now. Everybody can write what's given, write number 1, write what's given, justify that with the word given, and write number 2. So without really any thought, I can go ahead and put angle 1 is congruent to angle 7 and say given. And then know that on the next one here, we're ready to go. And we're trying to prove that the line L is parallel to the line M. Now this is going to be a short one. What I'll have a lot of times as students do is they'll go, okay, well, angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. VAT for vertical angles. And then angle 3 is congruent to angle 7. And I'll put that here. And that would be the transitive property, right? And then they can say L is parallel to M because corresponding angles congruent implies lines are parallel. But really, that you could do that, and that would be fine. And I would always mark that correct. But that would be 4 lines when you really could get away with 2, because notice that angle 1 and angle 7, they are classified as alternate exterior angles. Okay, so we don't really need to go through the process of proving the alternate exterior angles theorem when we've already proven it. We've already proven this, so we're going to use that now, and we can simply say that L is parallel to M. We're ready to do this. It's a 2-line proof. And why? Well, again, because 1 and 7, we've already shown they're congruent. I've marked it on the diagram. It's stated in the proof. It's marked on the diagram. And because of that, L is parallel to M. The reason is that alternate exterior angles congruent implies that lines are parallel. Okay, so really we can do that in 2 lines. No harm in using more than 2 lines as long as the logic is sound, but this is all that was needed. All right, looking at the next one. We are told that L is parallel to M and A is parallel to B. Now you might want to try to write a little smaller than me here, but this is what I've got to do on this thing. Got to get it a certain size so you can see it. All right, so both pairs of lines are parallel, so we'll go ahead and mark that. This is how we mark that lines are parallel. This is how we'd mark a second set of lines parallel. Use double arrows like this, okay? And then just take a look and see what you're trying to prove. Angle 1 is congruent to angle 5. And what do you notice about 1, 2, 3, 4, and 5? You'd want to include one or the other of these, obviously. You want to say something about angle 1 or angle 5. And I would say that angle 1 is congruent to angle 2. That's the first thing that jumps out at me, is that angle 1 is congruent to angle 2, okay? Now, the reason that angle 1 is congruent to angle 2 is because the line A is parallel to the line B. And something that I emphasized in a previous video, I'm going to say again, it's so important that you recognize which 2 lines are parallel are causing these 2 angles to be congruent, okay? L being parallel to M doesn't have anything to do with angle 1 being congruent to angle 2. M, the line, doesn't even touch angle 1 or angle 2. So it is the fact that A is parallel to B that we can now conclude angle 1 is congruent to angle 2. Now that's not important on this one because we had both sets of lines being parallel anyway. That's not always the case. So again, because A is parallel to B, angle 1 is congruent to angle 2. What are we using here? Well, you can look on your sheet. Those are corresponding angles. And again, since these 2 lines are parallel lines implies that corresponding angles are congruent, okay? So now what? Well, I would kind of take a page out of the book that we did on this one up here, right? Angle 1 was congruent to angle 7 up here. Well, angle 2 and angle 5 are in that same position here. So I can say angle 2 is congruent to angle 5. Now this time it is because L is parallel to M. Notice that line A is not touching angle 2 or angle 5. A and B being parallel doesn't have anything to do with this statement. It's all about L and M. L and M are the parallel lines. B is the transversal. 2 and 5 are alternate exterior angles. They are on opposite sides of the transversal, and they are outside the parallel lines. So that would be parallel lines. It's very important that you number too, right? So line 3 goes here so that I can match them up as I'm grading them, that I can match this explanation this reason up with this. Parallel lines implies alternate exterior angles are congruent. And then now we can say that angle 1 is congruent to angle 5, which is what we wanted to prove. Why is that? This is line 4, but angle 1 is congruent to angle 5. We've already shown it true on the picture. They all have single arc marks there, but now we can say it's true on the in the proof itself, and that would be the transitive property. Or substitution, this would be a situation where I would accept either one. This is the transitive property of congruence or substitution property. Okay, moving on. Here we have statements and reasons again. Angle 2 is congruent to angle 3. Again, a reminder, you should have attempted this already. If you got through the first couple and then you're waiting on me for this, that's kind of the bad way to do it. Try this one first. See if you can come up with something. Then play the video and see if you were right. All right, so we're told angle 2 is congruent to angle 3, so I'm marking them congruent like this, right? So there, that one's congruent to this one. And we want to show that 1 and 3 are supplementary, basically. That's what this statement says. The measure of angle 1 plus the measure of angle 3 equals 180 means that we're saying they're supplementary. So I don't know that right now, but what I do know is that 1 and 2 would be supplementary, right? Looking at angle 1 and angle 2, they form a straight angle. So measure of angle 1 plus the measure of angle 2 equals 180 is how we write that. Okay, and this is going to be the definition of supplementary angles. I believe I used that in a previous video, and I might have left the angles out there, definition of supplementary, but on the sheet, I'm pretty sure it's definition of supplementary angles. All right, so then line 3 is going to be a substitution. Because we know that 3 and 2 are congruent, we've even shown that on the picture, I can substitute 3 in for 2 into this statement right here. So I can write the measure of angle 1 plus the measure of angle 3 equals 180. You see? I'm taking 2 and 3, which are congruent, and I'm replacing 2 right here with 3, and I have this. Now, yes, this is substitution, and at this point, I probably can go ahead and give away to you that you could always use substitution, right? So there's a situation where it's transitive property or substitution, and there's a situation where it's substitution only. There isn't a situation where it's got to be transitive property. So if you want to be safe, I'm just giving this to you, you can always use substitution. That being the case, though, I'm always going to use the transitive property when I model it for you, because in my mind, it feels more like the transitive property. Angle 1 is congruent to angle 2, angle 2 is congruent to angle 5, so we conclude angle 1 is congruent to angle 5. But you would have been fine using substitution property here. It must be substitution property here. This is not the transitive property. This isn't 2 things congruent and then a third thing's congruent to one of the first 2, so then the first and the third things are congruent. That's not what this says. You are replacing 2 with 3. That's substitution. It has to be. Okay. Oh, and by the way, I don't put equals or congruent here because notice you're substituting a congruence symbol into an equal, a congruent statement into an equal statement. So I kind of just leave it off there. All right, one more. Angle 2 is congruent to angle 5. That's given. Always start with the given. Those are worth points, by the way. Saying what's given and writing given, that's going to be worth 2 points on a quiz if they're both blank. And then marking angle 2 congruent to angle 5 on my diagram. The only other thing that I notice about congruence right away is that angle 4 would be congruent to angle 2. Why is that? Angle 4 is congruent to angle 2. Well, that would be vertical angles. The vertical angles theorem says that vertical angles are congruent, and I can see that 2 and 4 are vertical angles, so right away I can say that they're congruent because vertical angles are congruent. Okay? And I notice I am using the word congruent as much as I can and not equals. We're kind of migrating away from the word equals and towards congruent. Congruent means equal measure, and we want to use the word congruent. Okay, finally, look at angle 2 is congruent to angle 5, and angle 2 is also congruent to angle 4. So we can say that angle 4 and 5 are congruent. And that would be the transitive property or substitution. Okay, that's all. Thanks for watching.